Okay, here we have a multiplication table. Turn in its diamond orientation. Now this multiplication table has also been referred to as the Pythagorean abacus. Now, if we look at the upper triangle of this multiplication table, we can see that we have the numbers 1 through 10 down the right side and the number 1s through 10 down the left side. And the squares having a number in each one are all colored in the upper section here. And then we have a boundary, a diagonal boundary of white squares right along the mid diagonal of the diamond. Now, this area here, triangular area, mirrors the triangle on the Pythabacus, with the colored squares mirroring the brown beads and the diagonal of white squares through the middle of the diamond mirroring the gold beads on the bottom of the Pythabacus. Now, if we go to a square with a number in it, such as in this case 12, then we will see that it will be the lower corner in opposition to the upper corner, where the 1 is, of a rectangular area that will include that number of squares. So we can see in this case we have 12, so we have 3 times 4 square in the rectangular area. We can go to another square, here at 10, and we can see that it's the lower corner opposite of an upper corner square that defines the number of squares in the 5 times 2 rectangular area, being 10. Now, if we go over here, we can see that we can find similar areas in the Pythabacus. And if we go over here to the Pythabacus and count down the right side, 1, 2, 3, 4, we can push out a group of beads over against the left post, and then count down 1, 2, 3, and we can push out a rectangular area having 12 beads. 3 times 4 equals 12, mirroring the 3 times 4 area in the multiplication table. We can also mirror the 2 times 5 by counting down on the right side 2 beads and pushing over the group of beads to the left post, and then counting down 1, 2, 3, 4, 5 beads. And now I'm pushing out a rectangular area that will include 10 beads, mirroring this rectangular area of squares in the multiplication table. Now, we can locate any of the colored squares that are above the white diagonal of squares, and the sum of the factors will be either equal to or less than 10. For instance, 25, we can go see that the factors for 25 equal 5 times 5, which of course we know equals 10. And if we go over to the 24, we can see that the factors are 6 times 4, which is 24, and 6 plus 4 equals 10. Now, the sum of the factors for any other of the colored squares above the one just above the diagonal white squares, the sum of those will always equal less than 10. But these products, 9, 18, 21, 24, and 25, then in the multiplication table, the sum of the factors will be equal to 10. Now we can see this over on the Pythabacus also. I can go 1, 2, 3, 4. And then I can go down the left side 1, 2, 3, 4, 5, 6, which is 4 plus 6 equals 10. Push out this rectangle, and we can see now that we have a rectangle of 4 times 6, which is 24, and the sum of the digits are equal 10, and the bottom bead is above the 10th rod. And we could also do 1, 2, 3, 4, 5, 6, 7, 8. And we can do 8 times 2, 1, 2, where the sum of the digits will equal 10. And we'll see again that the lower corner bead will be right above the 10th rod. And so anytime we take two factors with the sum of the digits equal 10 and push out those rectangles, the top bead will be on the 1 rod and the bottom bead will be on the 9th rod, just as we see in the colored areas over here in the diamond.